this is still, I mean, basically, this is what people still are using in industry. I mean, in different software engineering tools, even if you look at open source code, you still see this embedded in the code, right? So what it's saying is fairly straightforward, right? It's just a form saying, okay, what are the critical information about this function that the developer, tester, or another developer need to know, right? Name, function type, return, and what is this guy doing? Okay? Why are we having this? First of all, human beings don't have long-term, very strong memory in terms of keeping all these detailed information. The definition we come out with today, if we don't write them down, we'll forget about them tomorrow. So first of all, this is actually for your own benefit as a developer. You know what you have designed. You're not redesign the same view every day. Then you know, okay, your productivity cannot be high, right? The only thing we can do to improve productivity is checkpoint, checkpoint, checkpoint. We don't back off, right? If you go for 10 meters and back out 9.5, then you know your speed wouldn't be very, very high, right? So one thing to use this notion is that for you to write down the definition so that you remember it tomorrow. Okay, that's one purpose. The other purpose is really that you can give this to somebody else on your team to finish it up in the implementation stage. Okay, in today so in industry use a lot of agile approach, which is we basically have really quick cycles. So we're going to touch on that later on, some more when we talk about teams. But more likely, today, you're working on this module. Tomorrow, you will be switched off to work on a different module. And somebody else will be switched on to work on your module, but you half finished today. Okay, if that's the case, if you don't provide documentation like this, okay, which basically means that somebody else coming in there and basically knowing nothing. All right? So this is necessary in terms of, okay, you come in today we have stand-up meeting, I'm going to work on module, you're going to work on module number 1, you're going to work on module number 2, I'm going to work on module number 3. Actually tomorrow I'm going to work on 1, you're going to work on 2, 3, and so forth, right? However, if we do this switching, okay, if we don't have this, then basically I have to come to you and what do you mean, right? What is this function about? What is it trying to do? If that's the case, then our productivity will be greatly reduced. Basically, we spend all the time talking about it. Then you know you're not going to get the work done. All right? The hope is at the morning when we get into office, we spend like half an hour stand-up meeting. I hand over the module to you, you hand the module over to me, and I look at this and say, oh, I understand, I'm going to do my work for 6 hours. If I have a question in the middle, a burning question, I really text you, or we have a short meeting, or I just walk to your cube or table to discuss, and we come back and work on this. But there has to be a base, right? If you have nothing, then everything would become a question, right? That is for the purpose of, for yourself to keep track, and also for your team to share work. Right, you can define more. Then basically, for each function, you can provide a definition like this. The second thing, which is critical, that's why you guys. This is part of a quiz as well. Is you are writing code, right? Pseudocode means pseudo, which is this code doesn't execute. Okay, the code you are writing right now in my quiz, my recommendation or my requirement right now is for it to execute, right? So you should be able to compile. Actually, number one, you should set up a test first, because all these data structures and algorithm are fairly easy to set up a test. You should set up a test first, then write your code, right? Then when do you know you successfully have written the code? You have discharged all the tests, then you got your code, right? But that's really running code. That's actually better, right? And that's actually better thing to do. But in many other cases, I mean, in terms of design, we are going to use something called pseudocode, right? Pseudocode is basically hybrid of code and English, or Chinese if you like to. I mean, so I can give you Chinese pseudocode, but I think only one person here can probably use that document. Or I got something from some other weird language that nobody here can understand. So better to be English than something else at this stage, right? Okay, so why are you doing this? I mean, why don't you just write out the code? Why are we doing pseudocode, not code? Why, see, we are writing code in quiz. I mean, we just write code. I mean, that's it, right? So why you need pseudocode?
You want to plan all the details.
Plan all the details.
Yeah.
Okay. Good. That is, you want to thought about this thing, but if I write code, I give you all the details, right? Why are we writing pseudocode, not real code?
Because we're not so concerned about the syntax of it, right? We're more concerned about getting across the idea of what we're looking for.
Then if I get all the code, then there's no concern anymore. Then why is pseudocode used here, not real code?
Visualize the detail of the algorithm in pseudocode.
Yeah, you are actually providing the detail of the algorithm. Say this is how your get input actually works.
It's kind of like visualization.
Yeah, it's visual. This is code, right? This is not quite code, but close code, right? The more you provide me, the better. I would love it, right? So, yeah, why is this? Why are we using pseudocode?
Because
right?
actual code is hard to read. And
That's
so
one thing. That's one thing. That's one thing.
That-
More detailed?
Which one is more detailed?
This one's more detailed.
This one, in some cases, is more detailed. What do you think?
Because pseudocode strips away a lot of the language-specific things that you would have to do when you actually implement it.
That's right.
So if you haven't decided whether you want to do C or Java or Python, you can write pseudocode. And then
That's a very good point. I mean, a key point is writing real code will be a lot more tougher than writing pseudocode. Writing pseudocode, you can probably finish fairly quickly. I mean, in terms of minutes, hours. Writing real code, get it tested out. I mean, for a search method, we actually allocated you 20 plus minutes to get that function written. I mean, not even tested, and so forth. I mean, for more complicated design algorithm, writing pseudocode can be fairly easy. I mean, the reason mainly here is if you write a real code, it's going to take many hours. And writing a pseudocode probably in terms of minutes. Okay, just that this is a necessary step. We're going to the full code. Just that this is much quicker to get to than real code. And also, as you said, we're not even determined whether this is what language it's going to be, and what library we're going to use, and what data structure in some cases we're going to use, right? So in that case, pseudocode is your friend. And when you're doing code on whiteboard, remember, you're doing pseudocode. You're doing pseudocode. So you have to be clear when you go into such a whiteboard interview, right? You need to make sure one thing. Is this guy asking you to write pseudocode or real code? It's different. If he or she is expecting you to write code and you're starting to write pseudocode, that could be an issue, right? Because this man may be a very language-aware, detail-oriented person. He just wants to make sure you write code bug-free, syntax error-free, and everything on the board. And then you give him say, okay, this can be done by stack. Man, he must be pissed, right? So in that case, you need to figure out. Or I'm actually looking for pseudocode, and you start writing code. I'm thinking, well, it's going to take you a long while to finish your code because my algorithm is actually pretty difficult. You don't want to linger on the details in terms of code syntax, or even semantic construct, which is pretty complicated to write out on the board, right? But pretty straightforward to express with a short English sentence, right? So you have to be both. But both cases are possible, but you have to figure out what exactly your interviewer is fishing for. Okay. However, a lot of time, I think they are looking for this pseudocode because your interview process is pretty short. They are not going to be able to figure out. They're not going to pay attention too much on the syntax or semantic details. They want you to be able to come up with the algorithm. If that's the case, they're not going to be too concerned about. If they give you, say, oh, can you write that circular buffer on the board? Then your radar should be up and say, okay, I better write something close to code. If they are saying that write an algorithm used by Facebook, you know, I mean, there's no way you can write code to solve that problem. You better write pseudocode. Okay. So that is when your recruiter sends you an email say, okay, write this code and submit it online. You know, okay, that is not asking for pseudocode, all right? He or she is probably asking for code. Okay, but pseudocode is our friend because getting to real code takes a lot more effort, right? A lot more code, a lot more testing, compilation stuff going in. But pseudocode, you can write it out very quickly. And this is a great way for us to communicate our design of the algorithm. Okay? If you are assigned algorithm, this is it. They're going to provide algorithm description. Pseudocode is going to be your friend. Okay? So, used to be, this is, pseudocode is not even, so right now we are pretty much okay with pseudocode. But it used to be, so when I was a student of your age, the software engineering is much more rigid. So I remember I interviewed for a Japanese company, probably Toshiba, I don't remember anymore. So basically what they gave me is actually a full flowchart, like your homework, flowchart. My job is to actually fill out, to write the C code next to the flowchart to implement that flowchart. Okay? So that is called a programmer. The person who come up with those flowchart actually is called a designer. Okay? So there is clear differentiation between designer, architect, and programmer. For programmer, you are literally given a flowchart representation of this, and your job is to write code next to the flowchart. Okay? And I heard that they even have people who will actually take the code and go compile that code. Okay? That's a different job. All right? So yeah, so things have changed quite a bit. So you are doing everything now. Instead of very rigid job partition, you are actually doing requirement design, architecture design and the implementation and testing all together. As a software engineer now, it's really a software engineer doing everything, right? Before you have, our time we had really rigid classification of jobs. You actually classify to do one thing. You do one thing. But that's the time when one project lasts 5 years. Okay, it's certainly not our project lasts five weeks, right? So that's definitely not the same kind of situation. But hey, pseudocode still is golden standard. Okay, so if you are going to communicate your design, and pseudocode is pretty much what you have. If you are learning algorithm, you're taking algorithm classes, you know that those algorithm books are mostly written in pseudocode. and flowcharts, right? That's why you actually studied flowchart in your homework, because I mean that's actually one of the key things you typically see if you go to any software engineering company and the teams. I mean, you will find flowchart, pseudocode on their board. Okay, that is a token of languages we use to communicate as software engineers. So you better know it. You better use it. All right. So here, if you look at data flow analysis, you can do a lot more. So for instance, oh man, this is a pretty interesting design, right? They certainly, it seems like there's a major piece right there, right? So this must be the most smartest engineer must be really responsible for this particular piece, right? But then you know this have a single point of failure and everything. I mean, this is going to be a very buggy place. Okay, whenever you see this, you know this is going to be a very buggy place. Okay, so data flow analysis can help you. I mean, can identify this is a messy graph, and you know, man, this is a messy graph. Maybe we can do better. Oh, this is going to be the implementation of that. Or you can do better design basically by creating something called transactions. Okay, this is essentially where we had the concept of operating system. Okay? The concept of operating system basically came out of this kind of thing. Not operating system, sorry, databases. So the database is about transactions. Transaction basically one thing that need to be done, and need to be done once, and need to be done completely once. Okay? That's a database transaction. Essentially, that's also how you should be designing system. It's basically advanced form of data flow analysis. All right, if you're learning database queries, the fundamental database query is a data flow machine, data flow graph, like this. How data flow from one to another. Okay, this is you can see that even for such a small thing, data flow analysis, you still use it today. If you're programming in C, this is going to be your friend. If you're programming databases, it's going to be your friend. Doing data flow analysis, right? You can have very linear data flow like this, which is basically the fundamental thing called a pipeline. You can have a complex data flow like this one. You can basically disentangle this high coupling point, because that's going to be bad, right? You know it's going to be bad. The congestion, right? And then into transaction-based systems. This is how you define a transaction processing system. Pretty much, this is Amazon.com. This is Amazon.com, right? Certainly, they are more complex, but this is basically their model, right? You have raw transaction coming in, right? From from everybody here, right? Going to that, determine what is the transaction, carry out the transaction right to the database. If you have a magic wand, then you could basically say, I don't need Amazon, right? You give me transaction, I process transaction right in some data store. Hey, great, right? The problem is there's no magic, so basically that's why you have 50,000 programmers doing this, right? They really need to once you have bigger scale, you need bigger army of engineers, right? But if you are doing a very simple transaction system, a bookkeeping for yourself or bookkeeping for your family business, your programming level now is more than enough to take care of this problem. By doing data flow analysis with respect to transaction, you can get a small data processing system going with no issue. Okay, so you can see that why computer science and software engineering is helpful, right? So with your skill level, you can solve real world problem. You're certainly not solving Amazon problem, which having, how many transactions going on at the same time, but you can easily program a bookkeeping system for yourself, which probably have 1 or 2 transactions going on each day. Okay? For instance, you can easily write a small program which capture all the spending you have today, the whole week. Then easily you know how much money you are spending, right? So solving a real problem. Your capability now is more than enough to solve this problem, right? But all these techniques we are looking at here, data flow analysis, are 60 years old. They're still here because it is the right way to do it. All right, data-oriented design, pretty much eventually we converge into object-oriented design, which is to say we'll put data and the operations on the data at the same place, which is actually pretty natural. This is actually, this model actually was created for physicists trying to do simulation in biolab. Then everybody think, oh, this is a great idea, so everybody using it. Okay, from real life. So in terms of object-oriented design, right now we are, remember from object-oriented analysis, we have all the classes identified, their attributes assigned, and their methods assigned, and now we're just going to finish it up, right? Number 1, complete the complete class diagram. Then step 2, basically assign the algorithm for each method. First step is basically you are adding attributes. You are adding attributes to your classes. Not adding attributes, you already know the attributes, but you are actually nailing down the data type. Okay, and for this, for this method, you already get assigned. For each method, you basically have to define their signatures, input, output. Okay, this is called completing your